Hi, we're going to talk about lesson 2.4, real zeros and polynomial functions. How do we find all the real zeros of a polynomial function? There's two parts to this. The first part is using long division, similar to what you did back in elementary school. And then we'll do synthetic division as well. I think I'll do the two videos separately. So this will be the long division video. The first thing we need to understand is that if a number divides into another number, it's called a factor, and the remainder is 0. So if you look at something as simple as 24 divided by 4 equals 6, 4 is a factor of 24 because it divides it evenly, no remainder, whereas I get this 1/4 over here. Sometimes when you did this back in the day, 25 divided by 4 we could have said was 6, and then we had a remainder of 1. That was another way to look at it. So 4 is not a factor of 25 because it does not divide it evenly. The remainder is not 0. We do need to remember how to do long division in order to do our first steps here. And remember, you're looking for how many times does 4 go into 5? One time. 1 times 4 is 4. And then remember, you have to do minus. 5 minus 4 is 1. And then I drop the 4 down. 4 goes into 14 3 times, and I get 4 times 3 is 12. Again, that becomes a minus. That's going to be a very important part of our long division for polynomials. 14 minus 12 is 2. Drop this guy down. 4 goes into 22 5 times. 5 times 4 is 20. We have minus again, and I get 2, and that 6 comes down. And 4 goes into 26 6 times. 24, and I get a remainder of 2. Since I get a remainder of 2, you could write it R2, or you can write it as 1,356, and remember you can put 2 over 4, so 2 and 2/4, which would actually be 1,356 and a half. So just a little long division review there in what you're doing. I forgot to put my minus sign here. I'm a bad person. Don't forget the minuses, because when we bring this over to polynomial long division now, the most important thing is that minus step. So I'm going to take x plus 4, and I'm going to divide it by 3x squared plus 7x minus 20. So now you ask yourself, how many times does x go into 3x squared? Basically, you're looking for, what do I need to multiply x by in order to make 3x squared? And I'm going to do times 3x. So 3x times x is 3x squared, and 3x times 4 is plus 12x. The next part is probably the most important thing that we have to do. When we have to subtract both of these, because I want those 3x squares to cancel out, but you can't forget that you have to subtract this 12x as well. So it's kind of like subtracting this quantity, which means we're going to distribute that minus sign. So there's a few ways that I find students like to do this, and some like to circle that sign and change it so they know they've done it. So 3x squared minus 3x squared goes away. That's what we wanted to have happen. 7x minus 12x is negative 5x, and then I drop this minus 20 on down. And now I want to know, what do I multiply x by to get minus 5x? Well, that's going to be a negative 5. So negative 5 times x is negative 5x. Negative 5 times 4 is minus 20. And again, when I subtract this, I want to think about that as a minus sign outside. So this will become plus 5x, and this will become plus 20. You could have looked at this one a little bit easier, that negative 5x minus 20 minus itself is going to get you a remainder of 0. When I get the remainder of 0, I know that the answer to this problem is 3x minus 5. This also means that x plus 4 is a factor of 3x squared plus 7x minus 20. So because it divided it and got a remainder of 0, I know that this is a factor of it. It divides it evenly. Another way to look at this would be 3x squared plus 7x minus 20. If we did it factoring like everybody loves to factor, it would factor into x plus 4 and 3x minus 5. Another example, x plus 3, and then we can divide x cubed plus 4x squared plus 7x minus 9. I'll go kind of quicker on this one. If you want to look back at it, you certainly can. I needed to make an x into an x cubed, so I need an x squared. Multiply x cubed, multiply plus 3x squared. I must remember to subtract the whole thing, which means minus this and minus this. 4x squared minus 3x squared is 1x squared. Drop down the 7x, and I actually like to drop down the minus 9 as well. Bring them both down. Excuse me. Bring them both down, otherwise they can get lost in the shuffle. Again, x times what is x squared? I'm going to go plus x. That gives me x squared and plus 3x. And now I subtract here and here. This will become a negative. This will become a negative. Those go away. 7x minus 3x, 4x, and drop it down. I get minus 9. X times what is 4x plus 4. 4 times x, 4x, and 4 times 3 is plus 12. And now when I subtract the whole thing, minus 4x goes away. Minus 12, negative 9 minus 12 is negative 21. This is going to be the remainder. Remainder is here. And then we usually like to just go up top and do minus 21 over x plus 3. It's kind of the same idea as that 2/4 we did on regular long division. So x plus 3 is not a factor of that polynomial x cubed plus 4x squared plus 7x minus 9 because the remainder was not 0. When we have problems that have 2x squared plus x plus 1, it gets a little bit hairier. 2x squared plus x plus 1, and now I'm going to divide. So now if you stopped paying attention, pay attention right now, because I need to make sure that I have a placeholder for every degree on down. So I start with 2x to the 4th minus x cubed, and I need a spot for x squareds, so I have plus 0x squared plus 0x and minus 2. So I need to have a place for all of them, otherwise things get a little messy. So now 2x squared to 2x to the 4th, I need to multiply by x squared. So x squared times 2x squared gives me my 2x to the 4th. That's what's going to cancel out. That's what we'll like. And now I have x squared times x, which is plus x cubed. And now I have x squared times 1, which is plus x squared. So now when I subtract all of these, you gotta watch your signs. This will become a minus, this will become a minus, and this will become a minus. 2x to the 4th goes away. Negative x cubed minus x cubed minus 2x cubed. 0x squared minus x squared minus x squared. Drop down 0x, drop down minus 2. So they come along for the ride. Next, I need to get 2x squared to look like negative 2x cubed. So I need a minus and I need an x. Negative x times 2x squared is negative 2x cubed. And then I have minus x squared. And then I have minus x. And now when we subtract all of these, notice my negative sign will change everything to a plus. So these ones go away, 2x cubes go away, and then I have negative x squared plus x squared, and that goes away as well. So these ones canceled out, these ones canceled out, and I end up with 0x plus x. That's going to be an x and a minus 2. So at this point, we go back up here and say, what do I need to multiply 2x squared by in order to turn it into an x? And that's going to need to be 1 over 2x, and we don't do that. As soon as what you have down here has a degree that is smaller than up here, because this has degree 1 and that has degree 2, we're done. And this is the remainder. So how do you know when to stop? When you can no longer multiply that lead term by anything to make it into a polynomial. So I'm going to go with plus, and I'm going to put x minus 2 on the top, and I'm going to put 2x squared plus x plus 1 on the bottom. And again, this 2x squared plus x plus 1 is not a factor of this polynomial because we got a remainder that wasn't 0. So what we're kind of looking for is it a factor? One more example before we get on with long division and x minus 2, or excuse me, get into synthetic division, which is a little bit quicker. Plus 3x minus 8. So again, when I multiply, I'm going to multiply 2x and get 2x squared and minus 4x. And again, I can't stress enough about remembering to subtract both of them. So that becomes a minus and this becomes a plus. These ones go away. This is 7x minus 8. What do I multiply x by to get 7? It's going to be 7x, excuse me, plus 7 here. So I get 7x minus 14. Don't get lazy. Remember to minus, and this will become a plus, and I'm going to go with 6, and that's the remainder. Therefore, x minus 2 is not a factor of 2x squared plus 3x minus 8, and then I can just write plus 6 over x minus 2, and there we have it. So another way to look at this then is that x minus 2 times 2x minus 7 plus 6 over x minus 2 equals what we were dividing by there, plus 3x minus 8. So that's another way to write it if they want you to write it as a couple of factors. I think the next thing is synthetic division. I think I'm going to stop this video here so that we have a separate long division one and a separate synthetic division one. Be back with you shortly.